We have two hot plates here, one on the left that's on a low setting and one on the right that is at a high setting. And they're both boiling, but the one on the left is just barely boiling because it's at a very low setting, and the one on the right's at the higher setting. Which beaker is at the higher temperature? The one boiling a little bit or the one boiling a lot? Let's take a look. So in about a second here, you're going to see that my camera zooms in on the left-hand hot plate. And you can see that we're on setting 1 and that we're barely boiling. There's a few bubbles there. And as I scan upward, you're going to see that the temperature is about 96 degrees, which is a little low for boiling, but these are kind of cheesy thermometers, so that's not too bad. The higher one is at the setting of 10. That's about as high as it goes. And look at all those bubbles. And the temperature is 96 degrees. What's going on there? Why are they at the same exact temperature? Well, because that's the temperature that water boils at. We just saw a video where we had side-by-side hot plates, one that was on the low setting, one that was on the high setting. And we had basically equal beakers of water. One was boiling just a little bit and one was boiling a lot. So I want to kind of break this down as a particle diagram. And I want to start off by saying, let's say we start off and we're at 30 degrees Celsius. And I'm going to put in 100 joules of energy. Actually, let's see here. Let's see if we can change the font on that. So 100 joules of energy every second in 1 second. So every second, this hot plate's going to pump in 100 joules of energy. So when we're at 30 degrees Celsius, what you'll find is that 100 joules of energy comes in. And so that energy is like wiggling its way into the container, like so. And it is hitting a particle right here. And that particle begins to move faster. And it's going to bump into this particle, which is going to bump into that particle, which is going to bump into this particle. And then this particle is going to jump up a little bit, but it doesn't have quite enough energy. And it falls back down and bumps this one down, which gets hit by this particle. And maybe all this energy is now going into speeding these particles up. And we know that these particles are going to speed up because the temperature is going to go from 30 to 40 to 50 degrees Celsius. And this process is going to keep getting hotter and hotter and hotter as we keep pushing these 100 joules in every second. Now, once we get up to a hotter temperature, these things are now moving fast enough where they are taking bigger jumps and then falling back in. But some of them, maybe this one right here, is able to actually escape the container. And we call that evaporation, right? So it's evaporating. And as it evaporates, maybe it carries with it, let's say 60 joules of energy. So we put in 100 joules of energy and 60 of it left. So now only 40 joules is available to make these particles get faster and faster, right? So now our temperature, it's going up. It's like at 90 degrees Celsius, and then we hit 100 degrees Celsius, and then something special happens. At 100 degrees Celsius, this 100 joules of energy that's coming in, let's say I bring it in, 100 joules hits here. This particle starts going so fast that it knocks into this particle, and then this particle escapes with 100 joules of energy. And then the next second, another 100 joules of energy comes in, which hits this particle, which hits this particle, which hits this particle, which hits this particle, and boom, that particle leaves with 100 joules of energy. So now we've got all these particles flying out of the container, but the temperature stays at 100 degrees Celsius because every joule of energy that we put in from the hot plate gets taken out by another particle that leaves with that energy. So it would be like if your parents said every week, here's your allowance, you get $100 in allowance. And at the end of the week, your parents say, well, how much did you save this week? And you say, like, nothing. I don't know. I spent it all. I spent $100. Netflix, Apple Music, whatever, it's gone. So your parents are putting the energy in and you're pushing the energy out. there's no change. Okay, now what if they gave you $110 a week for allowance? Well, maybe you'd start to save some money. Now, here, let's take a look at the other setting. So instead of pumping in 100 joules per second, let's say that this one is actually putting in 1,000 joules per second. So 1,000 joules in 1 second. So now you have all this energy screaming into the container, right? I've got 10 of these arrows coming in. The same thing is going to happen where these particles are going to bounce up and then come back with that 1,000 joules. And this one's going to go up and come back with 1,000 joules. And then maybe you'll get some start to escape with 100 joules, but that doesn't matter. Like, it's only 100 joules out of the 1,000 that we're putting in every second. So the energy is building up in here and building up. So the particles start to move faster, right? And this particle starts to move faster and move faster. And eventually we're going to get to the magic 100 degrees Celsius number. And at that point, I've got 1,000 joules of energy coming in. So I need to get 1,000 joules of energy to go out. So I need all these particles to start leaving the container as fast as they possibly can, carrying with them 1,000 joules of energy. Because the temperature is going to stay at 100 degrees Celsius the entire time this thing is boiling. So I can't get above 100 degrees Celsius if I have liquid and the vapor at the same time, because for every joule that I push in, another particle leaves. You can see that in the difference between the containers, because the left-hand container had a little bit of steam up here, right? But the right-handed container, like, you can just see the steam leaving. That is energy leaving the container really quickly. So what happens if I turn up this thing to like 101,000 joules per second? Well, I would just get to 100 degrees Celsius faster. I would have more steam leaving every second, but I would stay at 100 degrees Celsius until all this water left and became steam. And it's not until the entire beaker is steam that I can start to heat up more than 100 degrees.